Hello, this is Robert Scuderian, and today we're talking about reading files, which is actually fairly important to us getting input into our programs that's actually meaningful. So far, we've seen input as in a user typing something into the input prompt, and you have a string. Well, what if we want more input than just one line at a time? So, if you had an experiment, this is computer programming for scientists and engineers. Something that everyone here has in common is you're going to be working with massive data sets, or at least big, or at least something you don't want to type in more than once. So, this can let us have repeatable experiments where we have our huge input file and then we can put it through our program that does all the processing for us so we don't have to type it into our TI-83 every time. 85? I never owned one. And what can save us heaps and heaps of time. There are some considerations we need to make, so let's see what it all is about. So we want to read a file full of data. So Python can easily read .txt files. And this is called ASCII, which is American Standard something II. And actually, we'll teach us something a little bit about how computers work. Computers only have a binary. Binaries are ones and zeros. And we know that we can make numbers out of them. So, well, it actually turns out, that's a nice way of seeing it, that there's a mapping that is numbers to letters. And we'll store letters as its numerical representation. And this looks like garbage, so that's nice. I'm getting farmer interneted again. That's okay. I can read this. Look it up yourself too. If you just type in ASCII table into the Google, you'll bring up some others too. But what we can get from here is capital A is 41. I'm going to write that down for myself. And that lowercase a is 97. And that numbers start at 0 at decimal 48. So the character 0 is number 48. Well, that sounds weird and dumb. But it's a generally agreed upon standard that lets us have this binary only format turn into numbers and letters and ways that we can actually interpret this data. Thank you for actually loading. That was terrible. So if you just follow these lines, we can see that there is a number in decimal and hexadecimal, which is base 16. Let's talk about number formatting and number theory. And finally, what character that will represent. What do you notice about this character set? Well, you can't even do French. These are English Roman letters. And that's it. Capitals A to Z, lowercase a to Z, 0 to 9, in that order. And it's kind of important. So we'll use that property later. Space and delete character is actually one of them, 197 or 127. And plus, minus, basically anything you can see on a keyboard is here, including this first column is all these weird control codes that are ways that we can work with text, which is very fascinating actually, but well beyond what we need to know for this class. But it's good to know that these are just numbers. And indeed, you can see I was testing it earlier, there are built-in commands that let us translate these. So if I was curious about what number Z is, it can tell me. And if I was curious if capital Z is less than lowercase z, well, capital Z is 90 and lowercase z is 122. And if you were ever given one of these numbers and told that it actually represents a letter, CHR, Ord is for ordinal, which is the numerical value of Unicode, ASCII. I really don't want to tell you the difference. What is 90? Well, it's going to tell me that it's a Z. You can actually go back and forth. Python lets you do that. If you're working in C or Java, you can just treat letters like numbers and add to them. So you could add 1 to A. I think you could do that in Python too. A plus 1? Oh, no. Okay. Fine. You would actually have to say ord of A plus 1. And then cast that into a char, a character. Then you get B. A plus 1 equals B. Programming's fun. So the important thing here is that we have just text. So use a text editor. Windows use Notepad. Mac text edit app. Spider can do this. We can create a file. I'm actually going to go with this view and say that's going to give us some junk. Save it. And instead of saving .py, we can say lecture words.txt. And you'll notice here it says all supported text files. So we actually know that this is just text. And it removes all the formatting because now these are just some words. And it is just words. So if I ever give you a text file, open it in Spider, make sure it actually makes sense. Make sure I didn't accidentally Mac format it and there's no new lines. I might do that. Even Macs and Apples still don't, Apples and Windows still don't get along. You think that all the problems in the world are solved? They're not. Even new line characters are not solved. So Spider is actually really quite useful for our uses. And there's actually some neat things we can do. That's me, hi. If I had a hypothetical file, I'm going to bring this onto here. And I knew it was a text file. What you can do is just drag and drop it in. And I have all of the text of Alice in Wonderland, which is fantastic. It is actually Project Gutenberg. If you need lots of text, there is free text of old books available. As long as it's public domain, they make files out of it. And you can put these on your e-reader and save yourself a trip to the library, which is actually very cool and compelling. I use the plain text UTF-8. UTF-8 is a superset of ASCII. ASCII is, oh man, I want to tell you so much about all this stuff. 1 byte versus 2 bytes. I will tell my class all about this in the lecture time. It's cool, but it is not something that is really important to this class. Just knowing that what a text file is, it is not a .doc file. You can have highlighting and pictures and word art and clip art inside of Word files. It is not just a text file. .docx is a text file, but not in the way that you'd expect. So if you're making a text file for yourself, do not use these. You can probably save as text file. Your mileage may vary. Just use Spider and save as.txt. And just opening these, guess what? It's Python. You just say open, and it's going to open a file for you. Of course it will. So let's actually do that. So I have read it, and I have some file, which I created earlier, which has some interesting stuff in it. And it's called somefile.txt. I could also open up lecture words. The important thing is that we just say open. I usually open it as my file, and I see this repeated back to me in tests, which I think is hilarious. You can name it whatever you want. This one just kind of works. So it is somefile.txt. And then if I run this, it's going to do nothing. Oh, that's not super useful. Oh, let's print it. We know how to print things. It'll print my file. I print out all the contents of my file, and it's going to be amazing. IO text wrapper name some file mode are encoding UTF-8. Great. Well, that's not super helpful either. So we must be missing something. So about this path, you can see that I just have file name. That looks in the same folder as the program. So if I have this here, you can see that lecture words is right beside read it, which is right beside Alice in Wonderland, which is right beside some file. Have them in the same folder. You can have more advanced paths and files in folders and stuff, and that is well supported, but for our use, just have them in the same folder. If you're using something cool like Visual Studio Code, check out where your Python interpreter is actually running. And I'm not going to help you with that. You can use slashes to show folders, and you can actually call it like a fully qualified path from the beginning of your hard drive. So if you're on a Windows machine, it'd be like C:/users/your cool name/documents/ best course ever / my file. If you're using a Mac, it would be from / and it'd be /users / your username / document / best course ever / your file. This is your best course ever, right? Obviously. You're enjoying yourself right now. So open doesn't read the file. We saw that. I've shown you that. It printed out something gross, that IO text wrapper garbage. That's telling us what this object is. Uh-oh, I said object again. What are objects? Data and methods to work with that data. So that means that I have this thing that is like a file, but I can't just easily print. So if I do this in a certain way, I can actually stream a file. And this is how I prefer doing it. You can do it your own way. I think this is compelling, especially if you have mega data sets. And that is what I'm hoping you'll have in the future and actually use this class in a meaningful, really cool way. And you'll send me an email about it and I'll be like, yes. Think about your favorite streaming service. It's going to load up just part of this huge file. So videos are gigabytes long. This video is probably 100 megabytes. And you only have this much loaded up because that's all you care about. Python can do that with files, and it can read it one line at a time from the file. So if I go over to my fancy device, generally, what I draw is something like this, where I have some words, and it looks like a bit like a document. And it's going to read in one line at a time, and we're going to use a for loop to say, for each line, do a thing. I apologize that I always am really abstract about this and say, do a thing. Process this line. Do something with this line of data. And then it will read the next line. And then do that thing. Do a thing. Do a thing. Do a thing. And it will only ever have one line in memory at a time. And memory is basically, think about a workbench. What's on your workbench? Well, our workbench has a fixed size in real life. And we have this current string on it, and we can play with it. And we throw that string away, put the next string on our workbench, and we work with it. We could have the entire document on our workbench, but why? Why would we do that? There's no compelling reason to do it, especially if we are processing this line by line. Load only what you need, and it's going to run smoking fast. So this is what we do. For line in my file, print line. Oh, Python, you're so kind. Why would you be that nice to us? We don't deserve you. For line in, and again, this is my file thing. It's totally a me thing. Print line. I can take that straight out of the notes, and because I'm so predictable, it just works. Oh, hi, this is a file. So let's look at this text and what's in the file. So that's some file. What do you notice that's different? There's spaces between the lines. There's a new line here and 2 new lines, or 3 new lines here. That's crazy. That doesn't look the same. If you think back to our last lecture, you'll remember that we use that line ending thing. So print always adds the enter afterwards. And what's happening is, let's put this into arrows. This is actually a really useful tool for smelling your data, and that is another Rob thing. Pew. Do it. So opening, and then the closing arrow is on the next line. Sorry, there we go. Meaning that there's a new line at each one of the ends of these files. And here, looking at this line, which is the last one, you can see there's a new line in there. And it's actually really hard to show you that without... oh, here. I just typed line. Perfect. That line had a space, /n. And if I look at my sum file, you'll see that is what my last line is. So it means we're getting that new line at the end of the file. That's all that means. So that print blah is not super great. There's actually something cool that we can use. We can actually get rid of all the white space using strip. It'll strip off the white space, and then it'll actually look the way we want. Or sometimes we can just work with the fact that it has a new line. That's fine too. but it's something to know that it actually gets the whole line, including the person hitting the enter key at the end. But there you go, we streamed a file. Now, if we're being good citizens, we want to do this. Some profs are really picky about this. My opinion, close the file. My opinion is that this is Python and who cares? If you want to be really Pythonic and save yourself from this, bonus. You can say with. You can look into this on your own time. I'm not super interested in this. F with open some file as F. Then we can have the same for loop, and that'll work the same way. Actually, I'll call it my file. Everyone always just calls it F in there, which is funny. And this will do the same way, and then it auto closes the. This is called a resource. If you're using Visual Studio Code, it'll complain about this or any other linter. Again, this is bonus material. If this doesn't make sense, you can just ignore me. Auto closes the resource. And the resource is this file. And it will close it, and it's great. Python, it does magically close these for us, probably. And the fact that we just have this one little file, we don't really have to close it, and that's okay. Some people really don't like me for saying that's okay. Okay, so this open thing, we've seen it. You can look at the Python documentation for open. For our uses, we're just going to say file name, and that's usually good enough for us. By default, it's RT, which stands for read text. Good. That's generally what we'll be doing. We can also write. We can WT, and then we can write to this file, which is actually pretty useful. There's a bunch more here. You can check those out. We might do it on a lab or an assignment, but we'll say, don't forget to open this with write, because whatever. And it is useful to write files too. Writing your output, if it's very large, very useful. Okay, so this file object, I've shown you .close. There's some other tools we can use. .readlines will read the entire file line by line. And this is a little bit of spoilers into our lists that we're going to talk about next class. And I'm going to restart I'm going to show you how to do that. I'm going to restart my kernel. So debug, run. No, I always forget. Oh yeah, the gear. Where's my gear? Oh, this is not going well. I forgot how to restart my kernel. There we go. Restart kernel. This is actually a really good idea. It'll clear all your memory and give you a brand new workspace. So this is me talking about that workbench. Now I have a clear workbench, and there's going to be no variables up here, and that's going to be really quite nice for me. There we go. So if I said myfile.readlines, it's going to give you an array of strings. We'll talk about what all those things mean in a bit, and you can actually see all the new lines. This is actually kind of nice to see. So I could replace this with myfile.readlines. And it'll run exactly the same way, except it'll load the whole thing into memory and then go through each line one at a time. Cool. And you can read the whole document into one big string. So over in my code land, I'm going to run this again. I'm doing a little bit of magic. My file, and then my file, Mr. File. Mr. File would be great. .read, and it's going to be one mega string of the whole entire file, and you can see all the new lines and everything is verbatim, and it's really good for reading small, short pieces of text, or if it's some kind of encoded thing, you can read in a file like that. Encoded JSON. Close the stream, and it is a stream, even if you just call .read on it. So there is one problem with that you will encounter. So I'm going to jump over to this before I talk about nested loops, because why not? I'll restart my kernel one more time. This used to be a gear. I'm mad they changed it. Restarting your kernel might take longer than my computer. Macs are a little bit quicker at this. Okay, so I'm going to open up my any file. I don't really care. And then I'm going to call .read on it. So it's going to be the whole file, my file.read. And hey, there's the whole string. So I want to read that again. I want to read it in again so I can do something. I screwed up that string and I'm going to read it again and it gave me nothing. That's an empty string in out3. Why the heck is that? Well, you have to think about this file as, well, a Word document. And you have a cursor in your Word document, right? So you have all this stuff and you say the end. Great. So when I open my file, my cursor is up here. And when I call .readLine, I can read one file with .readLine. It's going to move my cursor from there to here, the beginning of the next line. If I call readLine again, it's going to move that, my cursor from there to here. If I call read, it's going to read my whole dang file, and my cursor is going to be here. So that means it will have returned all of this, and then my cursor will be at the end. So if I call .read again, what's it reading? Nothing. There's nothing more to read because my cursor is at the end of the file. If you want to do, this is outside of class material again, if you want to do advanced file handling, there is actually seek, which will change the position of your cursor to anywhere you want in the file. We are not doing that in this class because that's advanced and annoying, and we can just read a file in once if we're being good programmers. So that is why read will return nothing the second time you call it. And we can actually see that again. I'm going to restart I'm just going to reopen my file here. So now my cursor is going to be at the top, and this is a brand new file object. My file.readLine is going to be one line, and then the next line, and then the next line, and the next line. So this is working exactly how I said it would work until I get to the end, and there'll be infinitely an empty string. And you can differentiate these by this line that actually had content had a new line character. This line has no new line character. So that means that it's not a line in the file like this one or this one. This one, there we go. It is the end of stream. There is nothing to read from this stream, so there's nothing to return. Not even a new line. That's an important concept with reading files. And somebody's going to get totally busted on that. They're going to forget to reopen a file, and they're going to be reading nothing from the bottom of the file. I promise. I will talk about that in the forum. Okay, so challenge. Count the number of characters on each line the hard way. And the hard way means, well, I'm going to show you the easy way and the hard way. So I'm going to take this. I'm going to open a new file. And this one is called challenge. No, the challenge is the next one. This is nested. Read. I almost said 2 R's, which would be pretty funny, I think, but I'm not going to do that. There we go. So I'm going to change this to Alice in Wonderland, which has a lot more characters than my first file. I'm not going to print my file because that's meaningless and stupid. So first of all, imagine the problem. If you can't solve this on paper, you cannot solve this on a computer. I have a file, and I want to read how many characters. That's letters, punctuation, spaces, new lines, the whole gamut. And I have this. Well, this is not super useful. There's actually 3 ways to do this. I'm going to do the hardest way first. So the hardest way is to read in a single line, and then we're going to have a single string. And we want a single string. So what we're doing is breaking down the problem so we can use the tools we know. Once we have a single string, we can iterate that string. We did this when we learned about for loops. We iterated over a string. Okay. And then for each letter, I can't help but talk and code. Count it. So let's solve that smallest problem first. So I'm going to comment this all out. There's a couple ways to do that. The clever person way is to use 3 ticks, which actually makes it into a string, but actually functionally is a comment. So I want to count the length of the string. So a line is equal to HELLO. I think I can count how many letters are in that, so I should be able to know what the result should be. And then count. Let's count this up. Initially there's 0, and if there's no letters or numbers or anything in here, the result should be 0, so that's what I want. And for letter in a line, count plus equals 1, and then finally print we had :d letters. Okay, so will this, whoop, dot format, spot the bug, count. So I'm going to drop count into there. And we had 5 letters. Hey, my for loop worked. So going back to my problem statement here, I have a single line, and this works. So now I'm going to read the next line. I'm going to continue counting, but I'm not going to reset my counter. But it's the same problem. Read the next line, same thing. So this is really for each line, do this. And when I say do a thing, it can be anything. It is do this. All right, count. Then we have that single string. So we have this code. This is the do this part, right? So I'm going to say for a line in this stuff, X. I will actually close it and be a good citizen. I'm going to take, I can rewrite that very easily. For a line in my file, colon, highlight this, tab it in, then I count it. How fast do you think it's going to be? Pretty dang fast. 164,202 letters. That seems pretty much right. I could read a smaller file in if I wanted to do a smaller test to make sure I can actually get a sense that it works. But I'm going to pretend that that's right. So I have nested loops. Is there an easier way to do this? Heck yes. I'm just going to say a comment, and this is number 2. Well, now looking at this code, can we make it better? Well, this is just getting the length of the string, right? I'm actually going to spell this out more. Is equal to count plus count. There we go. So read in every line. So going to our problem statement here. For each line, instead of doing that, I'm going to just redraw it. Bunch of lines. For each line, add length to count. And we have a length tool, so we could just use that. That's nice. And then I'll stream it through and should come up with the same result. That's good. But there is yet another way. But wait, there's more. What other tools did we have with this file? Well, we actually don't need this at all. I can get rid of this. Count is equal to the text equal to my file dot read. That returned this whole dang thing as one mega string. So we could get the length of that text. This will load the whole thing up into memory, but it still goes pretty dang quickly. 3 ways solving the same problem. Arguably, this last way is the best. This is a very nice way of illustrating what we can do with 2 for loops. Challenge yourself, and this is when you have to use nested for loops. Count the number of letter A's in the entire book. So we saw streaming line by line. We saw reading the whole thing. We saw using loops and fors to do some automated tasks for us. And I hope you're having a good day.